Look, applying your adhesive powder perfectly, it means absolutely nothing if your curing process is just left to guesswork. Welcome to this explainer. Today we're doing a high-signal, zero-fluff breakdown of the direct-to-film curing process. For those of us in print production, the curing tunnel is literally where the magic happens. Or, let's be honest, where your margins completely die. So today we are locking down the definitive standard operating procedure. We're going to map out the exact thermal metrics and visual indicators you need to standardize your curing phase, completely taking the guesswork out of your daily operation. Here's a quick look at our agenda today. First, eliminating curing guesswork. Second, establishing the strict thermal baseline. Third, reading those visual indicators. Fourth, managing environmental heat shifts. And finally, reducing production variability. All right, Section 1, eliminating curing guesswork. Okay, so the curing tunnel is a highly critical stage in DTF printing. This is the exact environment where the physical state of your polyurethane powder has to transition from a loose, matte solid into a flexible, heat-activated adhesive. And making that happen relies on a very strict balance of time and temperature. Now, you might be running a compact 30-centimeter system or maybe a wider 60-centimeter beast. Obviously, those different widths are going to dictate your belt speed. But here's the kicker. Regardless of your machine size, the baseline temperature absolutely must remain constant. You cannot just crank your temperature up so you can run the belt faster. It doesn't work that way. Moving to Section 2, the strict thermal baseline. We need to talk about the non-negotiable operational numbers required for properly melting this polyurethane DTF powder. This isn't about rough estimates. We aren't going by feel here. This is purely about the data. I want you to lock this number into your brain right now. 115 degrees Celsius to 125 degrees Celsius. For those using Fahrenheit, that's 239 to 257 degrees. This right here is the standard thermal range. This is the inescapable anchor of this entire explainer. And frankly, it needs to be the anchor of your daily operation. You absolutely must enforce this baseline. If your operators are just randomly guessing at the dial, you are introducing massive business-killing variability into your process. And there's a reason we're so strict about this. Operating outside the specific thermal window has exact failure states. If you run your tunnel too cool, anything below 115 degrees Celsius, the adhesive power will not fully polymerize. It simply won't form the chemical bonds you need for a durable transfer. But conversely, if your tunnel spikes too hot, jumping above 125 degrees Celsius, the adhesive actually boils. You are literally destroying its bonding capability entirely. Either way, both of these scenarios lead straight to ruined transfers, wasted film, and ultimately rejected products from unhappy clients. Let's get into Section 3, reading the visual indicators. So, the thermal metrics are your foundation, for sure. But your operators out on the floor, they need to instantly recognize the physical state of the film the exact second it comes out of that tunnel. The visuals always tell the truth about what just happened inside. And success looks like what we call the orange peel. A perfectly cured sheet displays this really nice uniform semi-gloss texture that literally resembles the skin of an orange. The adhesive should look fully melted and slightly dimpled. When you see that effect, it confirms you have hit that strict 115 to 125 degrees Celsius window perfectly. But what if you miss the window? Well, on one end, an undercured sheet is going to look chalky or kind of milky. This immediately tells you the powder has only melted on the surface, but underneath it hasn't properly polymerized. On the completely opposite end, an overcured sheet will look completely flat or even greasy. And if it looks greasy, it means you've boiled the adhesive and completely ruined its elasticity. Your operators need to be trained to flag both of these, the chalky and the greasy finishes, as immediate failures right off the belt. To make training a breeze, you really need to structure a mental cheat sheet for your production floor. It goes like this. Undercured means milky, resulting in surface melt. Perfect means orange peel, resulting in a fully polymerized adhesive. Overcured means greasy, resulting in a boiled adhesive. Seriously, take a screenshot of this, print it out, and tape it right next to your curing tunnel. It will drastically reduce the time it takes for a new operator to grasp this process. Section 4, managing environmental heat shifts. Now, here's where things get tricky in the real world. You might set your dial perfectly in the morning, but environmental variables are constantly going to try and ruin your consistency. Continuous runtimes practically invite ambient heat shifts. Picture this. You start your shift in a nice, cool shop and dial in the tunnel to a perfect 120 degrees Celsius. It's running beautifully, but as you run continuous production, that giant metal tunnel is holding on to excess heat. By the 3-hour mark, without anyone even touching the dial, the internal temperature can easily heat soak and spike to 130 degrees Celsius. And remember what we just talked about? At 130 degrees, your adhesive boils and turns into a greasy mess. Because of this notorious heat-soaking effect, you absolutely must intervene. Here is the step-by-step protocol to keep things in line. Step 1. Establish a strict checking protocol for your shift. Step 2. Equip your operators with a laser thermometer and require them to use it periodically. Say, every 45 minutes to an hour. Have them shoot the temperature directly on the film inside the tunnel. Step 3. Confirm those metrics are staying strictly within our golden 115 to 125 degrees Celsius window. If you see it creeping up toward 125 after a few hours of running, you have to adjust your dials down to maintain the actual true output temperature. And finally, Section 5, Reducing Production Variability. So why does all this granular focus on temperatures and orange peels actually matter to you? Well, because your print business is only going to scale when it becomes predictable. Locking in these strict thermal baselines is exactly how you achieve reduced variability across the entire production line. When your operators know exactly what an orange peel texture looks like and they actually respect and measure that 115 to 125 degree window with a laser thermometer, it completely transforms your workflow. It makes training a lot easier. It ensures simplified execution, and most importantly, it drastically improves consistency when that transfer finally makes its way to the heat press. You aren't crossing your fingers, guessing if the transfer will stick. You know for a fact it will, because you proved it back in the tunnel. So let me leave you with this. Are your operators currently guessing at the tunnel? Or are you actively enforcing this strict 115 to 125 degrees Celsius baseline to guarantee consistency? If there is any hesitation at all in your answer, it's time to implement this definitive SOP immediately. Stop leaving your curing process to chance. Lock down those metrics. Look for that beautiful orange peel and watch your production reliability soar. Thanks so much for joining me on this explainer. Get out there and start measuring those tunnels today.